Hi, in this Let's Create series we're creating a Crossy Road clone like this. In the last episode we created the starting area and added the character and character movement. Now we'll focus on procedurally generating the level with the grass terrain type and making our game isometric and having the camera follow the player. Let's get started. We'll create the grass obstacles first as we've got the existing grass prefab to start from. In the script directory, we'll create a new script by right-click, create monobehavior script, which we'll call grass, and we'll jump straight into the code for that. The grass obstacle is fairly straightforward. All we're going to do is create the grass we've used already and add some trees to it. The only slight bit of information we need is that we need to remember where the trees are so we can make sure the character can't move through them. So first up, let's create a reference to the tree. Create a serialized field of type transform called tree prefab. We'll use the transform as we want to position it, so that makes the most sense. Then we've got just one method in here. This is a public method as we'll want to call it from the game manager. The type is hash set containing integer values called init, and we pass in a float z, which will be the location where we want it. The int in the angle brackets is the type of data we're storing in the hash set. And a hash set is simply a collection of unique items that's really quick to ask if something is in the set. We want to store the location of all the trees, and in the code we'll be doing a lot of, I want to move to position X, is there a tree there? So having a fast lookup for that is good. If it was a list, you'd have to go through every element in the list until you check them all. So this is just a nice little optimization which will make our lives easier. How I'm imagining this working is the game manager is going to create an object from the grass prefab, then call this init function, and that'll be it done. So the first thing we need to do is make sure it's in the right place. So we use transform to get the transform of the object this script is attached to and set the position to be a new vector 3 at 00z, i.e. we'll be placing it at the next z location we need an obstacle. We now define our returning hash set, which we'll call locations. Initially we can pop this with two locations, -6 and +6. Our grass prefab has trees off to either side outside the movable area. By putting these values in here, it will mean we're never able to move onto those squares. Next we want to populate it with some obstacles. We create an int numTrees to hold how many trees we'll create, which will simply be a random number between 1 and 5. As these are integer values, the random.range function, the first value is inclusive and the second is exclusive, so 4 is the maximum number of trees we'll create. Now we can iterate over that with a standard for loop. In here we instantiate the tree prefab, saving the created transform into our tree variable. Passing in the current transform into the second parameter to instantiate ensures that the tree is created under this game object, so we don't clutter up our hierarchy with loads of random tree objects. Then we can choose a random location for it. Here our xpos is random.range between -5 and 6. It's 6 not 5 here because, as I've just mentioned, the upper bound is exclusive and we want +5 to be the possible location. We simply set the tree position to be a new vector 3 at our random xpos. 0.2 in the y value, so it sits on the grass, and at our z location. Then we can simply record the xpos of the tree by using the add method on the locations hash set. Finally, after the loop, we can return our hash set of locations. At this point, I will note a key deficiency in what we've created here. The random production of trees could be such that we create impassable terrain if the trees are created in such a way. Given the playing area is 11 wide and we create at most 4 trees, we'd have to get very unlucky for this to actually happen. Furthermore, it would require lots of grass obstacles in a row, and because we'll have roads too, it'll be very unlikely. Okay, jumping back into Unity, we can add this script now to our grass prefab. To this, we also need to drag on the tree prefab. To do this, we'll lock the inspector to keep our grass prefab there as we navigate to the tree object. Then we can drag it on and unlock the inspector again. This will add it to all the existing ones we've used to create the starting area. That's fine, we're not calling init, so no extra trees will be created here. Before we create the road obstacle, let's get the procedural generation up and running. It's often good to create things under a parent game object so the hierarchy doesn't get too cluttered. So I'll right-click, create empty to get a new game object which I'll call terrain holder. I'll reset the transform on this so it's at the origin. Let's jump back into the GameManager.cs script now. To our game objects section, we'll add a new serialized field of type transform for our terrain holder. And to keep things separate, I'll add a new header, terrain objects, to which we'll create another serialized field for our grass prefab. Rather than the type being a transform, we set the type to grass, i.e. the script, as the only thing we want to do after creating it is call our init method. To our game parameters, we'll add a new serialized private int called spawn distance, which we'll set to 20. This will be how far in front of our characters do we spawn the obstacles. As we move up in the game, we'll need to be constantly spawning new obstacles as we progress. Then in our variables, we'll create a new private int called spawn location. This will be the location of the next obstacle we want to spawn. And the last variable will be a big list of all our obstacles to date. This is a private list. The type is a tuple. A tuple is a collection of types. In this case, there are two things we want to record. The first is a float terrain height. So when doing the character movement, we know where it needs to end up. And the second is our hash set of ints called locations. We set this to new to just create an empty list to start. We've added some extra variables for game state, so we should update our new level methods to ensure these are set correctly. The first thing to add is to remove all the terrain. There won't be any at the start, but when we're restarting level, we'll need to clear it out. Firstly, we'll clean up our obstacle list. Here you can simply call clear on obstacles to remove everything from the list. Then we need to iterate over all our instantiated objects. We'll create them all under a new terrain holder, and this really makes it easy to iterate over. We can simply do a for each loop. For each child transform in the terrain holder, we simply call destroy on the game object associated with that child. So this will give us a clean slate. With this clean slate, we can then set the spawn location to 0. Remember, when we set up the starting area, we built that at z equals -1. So the first obstacle needs to be at 0. Then we can create the first spawn distance objects using a simple for loop and calling a new method, spawn obstacle. The spawn obstacle method is a private void function. It doesn't return anything. This simply at the moment will instantiate the grass prefab under the terrain holder and give us a reference to the grass script on it. Now we've got that grass script. In the grass variable, we can call init on it, passing in the spawn location. This will move it to the right location and spawn some trees. The result of that is the hash set of obstacle locations. So we take that and the terrain height, which is 0.2 for grass, create a tuple out of it, which is just done by putting the two variables within parentheses separated by a comma. Then this tuple can be put into our obstacles list using add. Just pay careful attention to the number of brackets in use here. That spawned it, and we've recorded where all the obstacles are. Now we can update spawn location by incrementing it. So next time, the next obstacle will go into the next place. Back in Unity, on our game manager, we can get the references we need. First is the terrain holder, and then the grass prefab. You can see spawn distance is set to 20 in the inspector, which should be fine. Let's hit play and check it out. Lots of grass objects have been created, which is nice, with varying amounts of trees in different locations. If we exit and run it again, then we should end up with a different level generated, which we do. Excellent. However, if you try to move, we still can't move out of the starting area. So let's dive back into the game manager and update the movement code. In our update function, we just need one addition, but it's quite complex, so I'll go through it slowly. We are currently allowing movement if the destination is in start area using our helper method. So to this, we need to add if moves are allowed outside of this. It's going to be in start area or, which for a boolean is the double pipe. We're not in the start area, so destination.y is greater than or equal to 0. And, double ampersand, there is not an obstacle where we want to move. To find out that, we'll need to look into the obstacle list we've created. We'll prefix this with an exclamation mark because we want the inverse. I'll come back to this to reiterate. In our list of obstacles, we have one entry per bit of terrain. So we want to look at the one for the terrain we're moving to. That is given by destination.y. That's a tuple with the terrain height and locations. So we just need access to the locations with .locations. Then we can use the list method contains to ask, is there an obstacle at destination.x? If there is, that would return true, but we want to know if there isn't an obstacle, which is why we had the exclamation mark before to invert it. That's it. The rest is fine left as it is. Whilst we're here, we'll also make it so we spawn new terrain as we move forwards. After the movement if statement, we'll add code to do this. This is while the amount of terrain we've generated, which is given by the length of the obstacle list in obstacles.count, is less than our current location, characterpos.y, plus how far ahead we're spawning obstacles given by spawn distance. If that's true, then we need to spawn some more to ensure we're always 20 ahead. We can simply call spawn obstacle. We should only ever be moving one at a time, so we should only ever need to add one more. But the while loop here ensures that if for some reason we've got a logic error in our code, we will at least always make sure we've always got enough terrain. This is a concept called defensive programming. We can now jump back into Unity, head straight into play mode and check out our terrain. We should be able to move around on the whole area. We can't go into the trees and we can't leave via the sides of the generated terrain. You can also see that as we move forward, more terrain is being generated. Crossy Road is an isometric game that's not got perspective depth like we have in the moment in our camera, so let's get that sorted. If we click on the main camera in our scene, we can see the properties of it. Let's switch to game view so we can see what we're doing. First of all, at the moment we're quite far away from our character because we wanted to be able to see our whole starting area. Let's get the camera a bit tighter on our character so we can follow them around. To do this, we need to move in closer in the X and Z directions, and Y feels about right. So I'll update these values to X equals 2, Y equals 4, and Z equals -3. I'll also move the rotation around so we're aiming a bit more up our terrain. I've chosen X equals 40 and Y equals -20. That looks good. The final thing to do is change this from a perspective camera to an orthographic one. We don't want things to get smaller into the distance. The style of game isn't like that. It also helps in an endless runner game like this because without perspective, we don't have to generate as many objects outside our playable area, as we have a much more fixed area that we can see. To do this, we look in the project area of the camera and you can see that project is set to perspective. We can change this to orthographic. We can see a bit much and the trees at the front are getting clipped. Let's reduce the projection size to 3. That means it'll see about 6 units tall, which gives a reasonable look ahead, but not too far. If we switch back to scene view, we can see our camera has moved. Now we can jump back into the game manager script and get the camera follow working. The basic camera follow is going to be very straightforward. In our update method, every frame will just ensure our camera is a specific distance away from the character. So at the end of the update loop, we'll add the camera follow. Here we'll construct a new vector3 camera position. This will be a new vector3 which we construct manually. Remember, when we set the scene up, we had the camera X equals 2, Y equals 4, Z equals -3. So the X for the camera will be the X position of the character plus 2. The Y position we will fix at 4 because we don't want the camera moving up every time the character jumps. And the Z position will be the character's Z position -3. We can then set the camera to this with camera.main to get the main camera in the scene. There is only one. Then we can get the transform of the camera and set the position to be our new camera position. Let's check that out. Back in Unity hitting play, we can see now that when we move about, the camera is following the reindeer. There are 2 issues to note. Firstly, the trees on the spawned areas are too big. We forgot to scale them down like we did in the starting area. And if your character goes to the edge, the camera follows right up, which means we can see well past our 3 rows of trees. The camera doesn't need to follow all the way over there, so we should limit it so our camera doesn't show lots of things outside of our scene. To fix our tree size, On the grass prefab, you can see that we just dragged in the model directly for the tree, so it will have whatever properties the default model has. Instead, we should make a prefab out of the shrunk version. In the Models Characters directory, drag the tree into the scene. Reset the transform so it's centered, then we'll set the scale for all of the axes using the link icon to 0.75. We can then drag this into our prefabs directory and delete it from the scene. Back on our grass prefab, we can drag in this new tree prefab into the tree prefab slot. Now when we start the game, the trees are a much better size. Let's jump back into the GameManager.cs code to get the restricted camera follow set up. In the update function, where we've just written the code, we'll just modify the camera position.x before it is set. The character moves between -5 and +5. Let's limit the camera to only follow as far as -3 and +3. Don't forget that our camera is offset in the x direction from the character by +2. So we really want to limit between -1 and +5. I've just added 2 to those numbers. When you want to restrict a value to within a range, we can use the mathf.clamp method. It's a float we're clamping, so that's all good. So the camera position.x equals mathf.clamp of the target camera position.x. Then the next is the minimum value, which is -1, and then the maximum of 5. That should be it. Let's check that out. Back in Unity, we can hit play and see what's going on. You can see that when we go to the left, that's looking good. We're stopping the camera in just about the right place. But when we go to the right, we see a little bit more past the trees than we want. So you can probably get away with stopping the camera moving earlier. I'll leave that to you to play with the values and see what you think looks good. Before we stop for this episode, I've noticed that when we're in game mode, the shadows don't look good now we're in the orthographic projection. This is because of the direction of our light. So I'll align our view with the camera by right-clicking on the camera and choosing Align View to Selected. I'll just move a little bit so we can see the trees a bit better. Click on the directional light in the hierarchy. Then we can adjust the Y rotation until we get some better aligned shadows. I think Y equals -50 looks good. Rather than the shadows lying along the line of trees, it now sticks out and breaks up the edge. That's it for this episode. In the next, we'll implement the procedural generation of the second terrain type, the road tiles. I hope you found this tutorial useful in some way. As ever, the full code is on GitHub and linked in the description below. See you next time.